The midpoint rule. We often choose the sample point to be the right endpoint of the ith subinterval, that I in there, because it is convenient for computing the limit. But if the purpose is to find an approximation to an integral, it is usually better to choose the sample point to be the midpoint of the interval, which we denote by x subscript I with a bar over it. Any Riemann sum is an approximation to an integral, but if we use midpoints, we get the following approximation. For the midpoint rule, we would take the integral that goes from a to b of the function f of x dx is going to be approximately the summation of I is equal to 1 to n of f of the midpoint times the delta x. And we can factor out the delta x and then multiply it by the summation, where delta x is equal to b minus a over n, and the midpoint is going to be half of the first sample point plus the second sample point, which would equal the midpoint of that interval. Okay, now let's take a look at example 5, estimating an integral with the midpoint rule. We're going to use the midpoint rule with n is equal to 5 to approximate the integral of 1 over x from 1 to 2 dx. So the first thing we need to do is we need to figure out, okay, we know that n is equal to 5. We know that f of x is equal to 1 over x. We also know that a, the lower limit, is 1, and we know the upper limit is 2. So let's find delta x. So we want to find delta x, okay, and then that's going to equal b minus a over n. So we have 2 minus 1 over 5, which gives us 1/5. Okay, so what do we know about the initial value, x subscript 0? Well, we know that x subscript 0 is the lower limit, which is 1. Okay, and now we know that when we want to find x subscript 1, well, that's going to be x subscript 0, which is 1, plus the value of 1 times 1/5. Okay, so 1 plus 1/5 gives us the following. 1.2. Okay, we want to find x subscript 2. We're going to take our 1 plus 2 times 1 over 5. And so 1 plus 2/5 is equal to 1.4. Okay, if we want to find x3, we know that's going to be 1 plus 3 times 1/5, which is going to equal 1.6. Okay, and then we're going to go to x subscript 4, which is going to be 1 plus 4 times 1/5, which is going to give us 1.8. And then the fifth is going to give us 1 plus 5 times 1 over 5, which then becomes 2.0. Okay, and so now what we want to do is we want to be able to find the midpoints. Okay, so we want to find what are the midpoints. So again, recall up here what the definition states for the midpoint. That means if we want to find the midpoint, which is the first midpoint, okay, well that's going to equal 1/2 times 1 plus 1.2. And so when we add those together and multiply it by 1/2, we get 1.1. And let's just verify that on our calculator really quick here. Alright, so if we take 1, add 1.2, and then multiply that by 0.5, then we get 1.1. Okay, and then we want to find the second midpoint, which is going to equal 1/2 times, now the next time we take it is the next interval, which is between x1 and x2. So we're going to take 1.2 plus 1.4. Okay, so again, let's just verify that. We take 1.2 plus 1.4 and then times that by 0.5, and that gives us 1.3. Okay, so now we want to find the midpoint at 3. So we take here, the points are 1.4 and 1.6. So we take 1.4 plus 1.6 and multiply that by a half, and then we get 1.5. And then the next midpoint is between 3 and 4. So we know that's going to be 1/2 times 1.6 plus 1.8, which gives us 1.7. And then the last one, the midpoint, is going to be between 4 and 5. So we take 1/2, multiply that by 1.8, plus 2.0, which gives us 1.9. Okay, now let's take a look at what this looks like visually. Okay, so here's our graph. Okay, so we have the function y is equal to 1 over x, all right, and we have our 5 rectangles. So let's take a look at our 5 rectangles. So again, we're going to the right. Okay, so we know that our first point is 1. And we know that this is going to represent the endpoint of 1.2, which is this one here. And then 1.4, 1.6, 1.8, 2.0. So let's go ahead and just label those. So these are the endpoints. We're not using those, but it's just good to be able to see that. So we got 1.6. We have 1.8, and then we have 2. Okay, so now we're going to take a look at the midpoints. So the midpoints are what we want. So we have 1.1, 1.3, 1.5, 1.7, and 1.9. So this midpoint represents 1.1. This midpoint here represents 1.3. This midpoint here represents 1.5. This one represents 1.7, and then this one represents 1.9. Okay, so now what we have is we have our midpoints. And now what we can do is we can go ahead and then determine what is the area of this. So let's go ahead and tie this all together. So for step 5, we know that we have the integral that goes from 1 to 2 of the function 1 over x dx. Okay, and it's approximately, by using this definition at the top here, we know it's delta x times the following. So it's going to be delta x times f of 1.1 plus f of 1.3, since those are the midpoints, f of 1.5 plus f of 1.7 plus f of 1.9. Okay? And so what this ends up equaling is the following. We know delta x is 1/5. So if we plug in 1.1 into the function, that means it's going to be 1 over the value of x, which is 1 over 1.1. Plus 1 over 1.3, plus 1 over 1.5, plus 1 over 1.7, plus 1 over 1.9. Okay, and so therefore, we get an approximation of 0.69198 for the area that is under the curve. Now the last thing we can state that since the function, which is equal to 1 over x for when x is in between 1 and 2, the integral represents an area, and the approximation given by the midpoint rule is the sum of the areas of the rectangles that are shown in this figure above.